Hello. I will try to solve this example test, and basically it contains 5 exercises, and let's try to see how those can be solved. And first, what I do, I just copy this template here and put it into my pie chart. Basically, I can read the docstring also here. In some cases, the text can be a bit different or maybe explains in more details, because in docstring we try to keep it as short as possible. So it might be good idea to actually look at the docstring and to compare with the actual text. But I guess we can work from here. So the first task is to write the function, or actually implement this function. Given number of days, we have to return how many of those days are work days. And we can say that the first 5 days of the week are work days and last 2 are not. And we start counting from the start of the week. So basically we can say that if we start from 1, 2, 3, 4 and so on, then this is workday. We can say it's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, and again. So we can say that basically those are all work days and those are not n, for example. Then work days and so on. And now there are different ways to solve this problem. One way would be to somehow actually loop over the days, kind of simulate. We start from the first day and second day and count how many work days we have during this period, which is doable, but it's not the best way to solve this problem. But we can try to solve it as that. So maybe you don't have any better ideas, it's still better than nothing. So I could say that let's loop over the days for day in days, yes. Not days, but range. So if it says that I have to calculate it for, let's say, 8 days, then for 8 days I would say that there are 5 weekdays and plus additional workday from here. Yes, workday. So, and now I start from the first one. I somehow have to know whether it's a workday or not, and so on. How to do that? So I have different values for this day value, the day variable. The first one is 0. So basically I somehow want to say that for 0, 1, 2, 3 and 4 I want to say it's workday, and now 5 and 6 are not. And now the problem is that somehow again I have to know that 7 and 8 and so on are again work days. So how to do that? Basically what we can do, we can use modulo here. So we can divide, as we know that it repeats after every 7 days, we can basically see what's the remainder after dividing the day with 7, for example. So I can say that, let's say this remainder is day, and this is a percentage sign, but it's called also modulo. So it's basically what remains if we divide day with 7. So now what we have to see is that let's see what happens here. So if I take 0, 1, 2, 3 and 4, if I divide them by 7, the remainder is the same number. And with 5 and 6, again the same number. And if I go here, if I divide it by 7, what remains is 0. So in that way it makes sense. So here I would also get 0, 1, 2, 3, 4 and so on. And the nice thing is that even if I go over 100 and so on, everything remains the same in that sense that every first and second and third and so on days give me the same result if I divide it by 7. So 7, 8, 9, 10, 11 will give me that, and after that we will have 7, 8, 9, 10, 13, I guess, and 14. No. 12 and 30. Those will give me 5 and 6. And again, if I start with 14, 15 and so on, I would still get 0, 1, 2 and 3 and 4. So basically we can say if the remainder is, let's write it so, if the remainder is larger or equal to 0 and is, for example, less than 5, then we can say that it's a workday. Let's have a workday, well, let's just use count here. If it is, then we just say that count, we add 1 to the count. And there's nothing else to do actually. I could write else here, but what do I do here? So basically I do nothing and I don't even write this else part. And now I can say after this for loop I can return count. Let's have some examples also. I just used the same ones here. And I will add this main part. In PyCharm, if I just write main, there is this template. Basically, I can just hit enter and it writes me this if condition. I don't have to memorize it by heart. Okay, I just paste it here. Okay, I have to print them and also I have to remove those here. And let's see what my code does. I execute this one and I see 7, 3, 5 and 11. Yes, exactly as expected. Of course, it's always wise to try your own inputs, and we often don't give you all the pointers to edge cases, so you have to try to think about them yourself. So for example, what happens if it's 0, but here we cannot have 0, so probably it's said somewhere or not. Or maybe, yeah, if we, for example, if it's not said, and probably if you write 0, I would like to get 0, because within 0 days there should be 0 work days. I guess my code already does that, so yes, I get the same results. Now, this is one way to do it, but actually you can also do it without this loop, because what we can say that first, if we know how many weeks it is, we know that for every week there are 5 work days. So I can calculate the weeks. Weeks are actually, if I take the days and divide it by 7. So if I have, let's say 7, if I divide it, then I can say it's a 1. Okay, here what happens is that if I divide it by 7, if I divide 1 with 7, then it's 0. So yeah, basically it's a 0 weeks. Now if I divide 7, it actually doesn't matter. Let's see where we get with that. So basically the idea is that I want to see how many full weeks we have, and then I can see what's left. Days left is everything which comes after the last full week. And how to get that? That's how we can use basically the modulo again. So I can do something like that. I take days and take the remainder of when we divide it into 7. So basically the idea is that I know that there are, for example, let's say there's 1 week, another week, and so on. So if I know that, for example, we have 3 weeks, then I know that there is a 3 times 5 workdays, because for every week we have 5 workdays. And now if I, for some reason, also have 1 extra day, so it's basically 22 is the input, 22, yes, because 21 divides into 3 weeks, and the first day over or after the last week marks the workday also. Of course, if there are, let's say, 5 days after the last week, then only 5 workdays are in that week, basically. So if I have 20, what's that, 27 and 26. Okay, 26 is still okay, because I divide 21 into 7 gives me 3, and everything besides that, let's say 27 minus 21 is 6. Okay, then we will have workdays 22, 23, 22. Those are all the workdays. So the 27th day is not workday anymore. So it's always wise to write, especially those kind of mathematical things, down. So you kind of see the connections here. So you see, for example, why 27 acts differently than 26 and so on. So if I take this, basically the reminder is the same. I wrote as a minus here. The idea behind this subtraction was that I take the full weeks, I get 21. Now I can subtract this 21. But basically the idea behind the modulo is the same. So I take whatever is left over from the last week. So basically it should be the same as doing this. I should get 6 again. And yeah, now I can see what to do in those different cases. So if this is bigger than 5, then we probably can only take 5. But if it's smaller than 5, then we can take whatever is left over. Now, the thing near 7 is also a tricky one. So let's say if I have 0, yeah, with 0, we can say that there is 0 workdays. If it's 1, then I have 1 workday. So now I have some additional things here. Now if I have 6, then inside that we have 5 workdays. And if I have 7, I have also 5. And now if I have 8, I will get 6 workdays. I will write down also the 5 here. Then basically the cases are covered. The 0 is actually not so, it's a bit different example, or this 0 I just exclude for now. Let's write here that this is where the week is ending. Now if I take the modulo, let's write it here. What is the modulo of 7? I will get 1. There are different numbers here. Then we have 5 here. We have 6 here. But here we have 0. And here we have again 1. And the other thing here is the division, or integer division. So if I divide it into 7, how many parts I get? Here we have again 0, but here I already have 1. So if I just look at that, I could say that 1 week is passed here. It depends. It's not so wrong, because actually it is. After the 7th day, 1 week is passed. But now I have to see that how do I write my formula so that it actually works uniquely or generally for every input or every different number of days. And here I can say that if I have those two numbers, I can come up with the result here. So if I have 0 or whatever, let's maybe write some more examples here. With 7, and this is 2. So basically what we can see that if I take this week and multiply it with 5, that's the idea. If I have 1 week, I have 5 work days inside that. Here also 5, here also 5. And then I can add this number here. This makes sense. So if I multiply it with 5, I get 5 work days because it's 1 full week. And I have 2 additional days here. So that's why we can write it as that. And here also I get 5 plus 0 times, because the modulo is 0, I just add the 0 here. Here I multiply the 0 with 5 because I have 0 weeks, and this gives me 0 days. Work days here also 0 weeks, 0 work days, and add this number here. And the special case is here. So with that I cannot add 6, I have to add 5. And let's try it with a larger example. What was here? 15, for example. Give me 11. So 15 should give me 11. So if I see what's the module of 7, we can say that it's 1. And here, if we divide it into 7, we get 2. And if I multiply 2 with 5, I get 10 plus 1 is 11. So we can basically say that I can return weeks multiplied by 5, because for every week we have 5 work days, plus days left, although not here. So this should happen again at 13, I guess, and 14. So with 13 I should get how many? 10. And here also 10. And here the division gives me 1, yes, and this one gives me 6, and this one gives me 0. So if I take this one and multiply it with 5, I get 5, and if I add 6, I would get 11. But that's not gonna help me, because only 5 out of those 6 are work days. Now I could have a if condition here. If the days left is more than 6, then let's use 5. But I can also write it as that. I use min from day left and 5. So whichever is smaller out of those two values, I use this one. If this is 2, I will use 2. If this is 6, I will use 5. So let's see whether my idea here works out as well. So I get the same numbers here. And if I really want, I can actually change those or replace those variables here into this return, so I can get everything with one return sentence, or with one one line of code for that sample. Okay. Let's see the next exercise, sort the sum. So given two ints a and b, return their sum. However, if the sum is in range, or sums in range 10 to 19 are forbidden. So both included. So in that case, just return 20. So basically we can just do it as written in the text. So I can say that total is a plus b. And if the total is within this range, so we can, let's say 10 is smaller or equal to total is smaller or equal to 19, then we say that total is actually 20, and then we just return total. There are different ways to how to solve that. This can be done with one line also if really needed, but that's not actually necessary. Here I can also write if total in range 10 to 20, and range works so that the first value is included, the second one is not included. That's why I write 20 here. So the 20 itself is not included, but the 19 is. So, and if I really would like to write it in one sentence, I can write it as return a plus b if a plus b, or okay, I return 20 if a plus b is in range, and then the 20, else return a plus b. So basically this is the same code. I just wrote it in one line. So it returns 20 if this sentence is true, if a plus b is in range, but else return a plus b instead of 20. So those are the options, but it's really fine to just write it like that. So extra end, given a string, return a new string made of 3 copies of the last 2 characters of the original string. String has always always length of 2 at least. So, but here actually this is probably the easiest exercise from that set. So basically I just have to take the last 2 symbols. To do that I can use slicing. -2 is the starting index that is counted from backward, so it's 2 last symbols until the end, and now I just have to multiply it with 3. So basically that's the whole idea here. This is really easy compared to this workday exercise, for example. Now this fourth one is actually tricky in the sense of the text, or how to understand the text. Basically the idea is that we take the element of the last element's value. So we take the last element and we take the previous, we take 2 last elements, this here 2 and 0, and now we use them as indices. So first I use this 2 as index, and I get actually the same value here. So basically this is 2, and if I use this as index, I will use this one here. So basically I add up those values which are at those indices which are 2 last values. So here I have 1 and 7. I can use 1 as index, and I get this 1 here. If I want to use the 7 as index, then I get an error. So in that case, I just use this value. Here, basically the same example, but the first value is too large, and then I can only use this one, and this gives me this element here. And here I get 0 because both those values are too large, and then I just use 0 instead. So basically I take, let's write it in code, then it's even easier. So what I do, I take the last value. So what's the nums? The last value is -1, and the second to last value is -2. So I have those values. Now if this a value is larger or equal to length of numbers, so if it's too large, then I use 0 instead. If b is out of this index range, I say that use 0 instead. And here I just return not a, but return nums at position a plus nums at position B. That's why I actually need those if sentences, because if I take something which is too large, I would get an error here. And that's what it's said also in the text. If it's too large, then just use 0. Okay, sorry. And now what happens is that it uses 0 as index. Okay, I have to modify my code. Okay, basically the idea is that here I return new values. Let's use AA and BB here. And here, if it's too large, I say that this AA is 0. Otherwise, I say that AA is nums at position A. And here the same. BB is 0, else we say that BB is nums at B. Yes, so basically I just I have to add two numbers, AA and BB. AA I get so that I take the last element and try to find the element at this position, this one here. But if it's too large, then I just use 0 as a AA value. With BB it's the same. And that's the idea behind this exercise. But yeah, the main thing is to understand it and also check always the examples. This should give you some pointers, or just ask. And then there is the last exercise. I have numbers. I have to find how many pairs there are so that one is basically the factor for the other. So if I divide it, nothing remains. Then how to do that? Basically, one way would be that I can, let's see. Okay, we have unique integers. So basically, I have to compare every element to every other element. So let's do that. For I, let's say number in numbers. And now I take the second loop where I do basically the same. I just loop over the numbers, but I have different variable here. So basically I take the first value, for example, this one, and now I in the second loop, I go over the whole numbers. I compare 3 with 3, 14 with 12, and with 6. Then I take 14, compare it with 3, 14, 12, and 6, and so on. And now, if I do it like that, what happens is that if I find that 3, okay, it doesn't actually matter. The thing is, I compare 3 with 3 also, so maybe it's not the wise idea. Let's make it so. So let's just do something like that. If the number is the same as the second number, then just continue. We don't compare, one with another. And let's just count how many pairs we have. In order the pairs to work, I just basically have to do something like that. If number divided by another number gives us 0 remainder, then I just say that count is increased by 1, and now I just have to return the count. And it's easier, I don't really have to show the pairs, I just have to count them. So basically I compare every two numbers, divide one by another, and see what's the remainder. Yeah, that should basically work. If I compare 3 with 6 and 6 with 3, I get different results. So if I divide 3 by 6, I would get 3 as a reminder, but if I divide 6 by 3, I get 0. So that's why, and because we have unique numbers, I don't have to worry about that I get duplicates into my pairs. So that should work. I can always see what's the result here, for example. Print that out, and it gives me 4 here. So this is one way to solve it. It looks harder than it actually is, but the thing is that you have to use one for loop in another. Okay, but thank you.